so I'm back, and hopefully in that last question you answered argon would have a greater ionization energy than sodium because there's more protons, so there's a stronger force holding those electrons in, so it would take more energy to rip one away. Okay, so as you go across a row, ionization energy increases. Okay, and again, you might remember that as you go across a row, atomic radius decreases. Okay, and both of those things are explained by the fact that the force of attraction is greater. Okay, all right, so on your periodic table, actually I should say, here's our trends for ionization energy. As you go to the right, the ionization energy gets bigger, and as you go from the bottom to the top, it also gets bigger. Okay, so we're going to draw these on your periodic table in a second. Okay, but that is the trend, and here's the explanation one more time. Okay, so as you go down a column, ionization energy decreases because those electrons are farther away. There's more energy levels, there's less force, so it's easier to take one away. There's less energy needed. All right, and that is shown here. Okay, and as you go across from left to right, ionization energy goes up. There's more protons. The electrons are held more tightly. It requires more energy to remove one, so ionization energy is greater. Okay, and that is shown here. All right, so here's the summary, okay, and we're going to draw this on your own periodic table here in a second. Okay, you can notice really that they're opposite. Atomic radius increases to the left, ionization energy increases to the right. Here, atomic radius increases as you go down, ionization energy increases as you go up. Okay, and remember, the main explanation for all of this depends upon the force of attraction between the outermost electrons and the protons. Okay, as you go down a column, you're adding energy levels. As you go across a row, you're adding protons. Okay, so let us get out your paper periodic tables. Take out your periodic tables, and let's just label these so that you have this all labeled. Okay, I'm getting my camera open here. All right, so hopefully you can still see this. Here's my yellow periodic table. It's white actually, but it's the same as your yellow one. Okay, so get a pen or a marker or something and add some arrows onto here. Okay, so as you go to the left, I'm going to label this one atomic radius. Okay, when you go to the left, the atomic radius gets bigger. And over here on the right hand side, it is smaller. Okay, because there's more protons pulling electrons in more tightly, which makes the radius smaller. Okay, and then as you go down a column, okay, I will label this atomic radius, AR. The atomic radius gets bigger, okay, because there's more energy levels, more energy levels. The distance is greater between the outermost energy levels and the protons, so the force is less, and up here the atomic radius is smaller for the same reason. Okay, there's fewer energy levels, so the force is greater. Okay, all right, so let's do the same for our ionization energy. Okay, I'm using a different color. Doesn't really look like it, but it is. Okay, this is green. I'm going to label this arrow ionization energy. As you go to the right, the ionization energy gets greater. Greater ionization energy. Again, there's more protons that are held more tightly. Okay, it takes more energy to rip one away. And over here on the left, the ionization energy is lower. It's easier to take an electron. Okay, and down here, so I'll write this other arrow right here. Okay, as you go up like this, ionization energy increases. Bigger, I guess I'll write that right here. Bigger because there are fewer energy levels and they're closer. They're held more tightly. It's more difficult to take one away. And down here, ionization energy is lower, again, because the force is less. Okay, so hopefully that helped, and I hope you all have a great day. Thank you very much.